So for part B, we write the first four non-zero terms of the Maclaurin series for f prime, the derivative of f. Express f prime as a rational function for df of I of x less than r. Okay. First it says find the derivative, and I'm thinking, well, I could just take the derivative of that. In fact, I'm gonna do it. Alright, so let me write that down so I don't get confused. So, there I wrote it down, but this is the same thing as f of x, right? It just goes from 1 to infinity. Well, that's great. That's fantastic. So that equals, so f of x equals that. So I can take the derivative. F prime then is just the derivative of that stuff. So I'm going to go inside my summation. Maybe I'll move that down a little bit. So I'm going to go inside my summation right here and take the derivative of anything that has an x. Now see this? This is just a coefficient. No x's here. No x's in this term. This is the only term I'm taking the derivative of. And I would just take the n. I'm using the regular power rule. Move the n down. So actually, let me copy the coefficient first. So copy the coefficient. Then I get n x to the n minus 1 because I just take that down and subtract 1 from the exponent. That's all I got to do to take the derivative. There it is. That's f prime. But some stuff cancels. Look at how beautiful this is. And so I got that right there. Oh, look, these have the same exponent. So I can simplify a bit further. And then I have something like this. And I think to myself, oh my goodness, this looks terribly familiar to me. Perhaps I can change some of the indices. Because when I plug in 1, I'm actually plugging in 0 to the exponent because I get 1 minus 1. So that's just the same thing as 0. And when I plug in 2, I'm actually plugging in 1. So why don't I just start it out at 0? The first thing that's going to be here is 0. Right? I could even write out some terms. So I would have something like this. This to the 0, right? 1 minus 1, that's 0. And then I'd have plus and negative 3 to the x, or 3 times x, rather. And then I plug in 2 the next time. So that'll be 2 minus 1. That's just 1. Do you see how it's just counting up? All I have to do is I could just start at 0 to begin with. That's what I'm doing. Okay? Do you understand? Maybe? Well, that's how it changes. So this is the same thing. Because if I wrote those down, I could write down the same thing. I just copy it. Do you see it? You can't answer because this is a video, but I hope you see it. I really do. So then I have this, and I'm thinking like, wait a minute. I have this list of things in my brain, and I see that if I have something like this, so like this has crazy factorials, this crazy factorials, and not that crazy, but a little factorial there. And this says, multiply by some, maybe I could rewrite it like that. I could. But this one has a negative 1 to the n. I suppose I can make it a negative 1 to the n and then times 3x. I could use this. Do you understand? I can rewrite this in this form, and then I could use this. But this is already in that form. Okay. And it has nothing at the bottom. It has nothing to do with the choose function. So, this is actually the same thing as when I take this. It's that to this. So this 1 over 1 minus negative 3x. Yeah, because instead of minus x and the x there, I have a negative 3x. So I put a negative 3x there. So that's all I have. Very good. That's it. So that's the part where I took the derivative. Okay, because that's what it said to do. Oh no, I'm not even done yet. Good thing it said write the first 4 non-zero terms. I almost forgot to do that for the derivative of f. And express f as a rational function for that interval. Well, I already know this is good for for all x's in that interval that I found in A. So it actually works there. So this is the same thing as 1 over 1 plus 3x. And I don't have to write that. I would just leave it like that. But that's what f prime is. But I still have to write, so that's actually the second part. Express that as a rational function. Done. Did that. The next thing I want to do is express the first, how many? How many? First 4 non-zero terms. So I kind of started that. Maybe I'll keep going. So that would be plus, and then I'll actually like simplify it a little bit. I don't know if I need to, but I'm going to. Negative 3x to the 3. I guess those are non-zero terms, right? So what does this come out to be? I'm going to do it in green, and I'll put a box around it. So those are, this is just 1, and then minus 3x, and then plus 9x squared, and then minus 27x cubed. And those are the first 4 non-zero terms. Easy. I mean, I guess that would have been okay, but I'm going to write it out just to be safe, because that's an easy calculation that I don't want to screw up. I mean, I know I'm not going to screw up. So there's that, and then there's that. So that is part B. And we took 6 minutes to explain it, but it wouldn't take 6 minutes to do it. It surely wouldn't. Unless it does, but hopefully it doesn't. Maybe it does. That's okay too. You just got to practice more. All right? Okay.